Yeah.
Then we have waves.
Yes.
So how does it work about now? Just see. Now understand. So let's take an example of this particular bob. So we have this bob, and this bob is being pushed. It goes about the same distance. It goes about the same distance. So it goes up, goes here, and comes down back. So first thing that you have to understand that if this is the particular point, you know, understand now. So here is the shadow here. Here is the shadow. So corresponding to position A, this is the shadow. Corresponding to position B, this is the shadow. Corresponding to position C, this is the shadow. Again corresponding to position D and then corresponding to position E. So basically the shadow is going here and there. So that this is x equals to 0 and this shall be x equals to A. And the radius is also A. Right?
Yeah.
So how is the shadow moving? So let me just understand. So if this angle is theta, you tell me what shall be this displacement, because here my shadow initially was corresponding to this point. Yes or no? My
Yeah.
shadow was actually corresponding to this green line.
Yeah.
Then actually when the bob actually moved here, the horizontal distance that it has moved is this distance x. And don't you think this is the same distance, this x?
Yes.
So what is the x distance in this example? So this is my a, because a is what? A is I am taking the amplitude, and a would be the radius of the circular motion. Because you
Yeah.
understand, for me, a is nothing but just the maximum displacement.
Yes.
So in this example, when I'm comparing, this motion with the circular
Yeah.
motion, the SHM of the shadow with the circular motion. So what distance do you think should be x? So x should be what? So theta is here, x we have to find out. So for theta, x is perpendicular, and for 90, a is hypotenuse. So can I say
Correct.
x over hypotenuse, that is perpendicular over hypotenuse. So that shall be x over a, that shall be sine theta. So x shall be a sine theta. Yes or no? Isn't it?
Yes.
And when we are saying that
Yeah.
x is equals to a sine theta, what extra do we know? Have we learned in the previous classes that theta over time is velocity, omega angular velocity? That how much
Yeah.
angle we are traveling per second is omega. Angular velocity. Angle traveled per second shall be omega. So can I say theta shall be omega t?
Yes.
And if theta is going to be omega t, x shall be, can be written down as a sine omega t, because I can substitute that theta right here, isn't it?
Yes.
So
Yeah.
when x is equals to a sine omega t, this is my displacement of the shadow. Are you understanding? The x is a sine omega t. Understood or not?
Yeah.
If I know x, so what is dx by dt? What is x? That is the rate of change of displacement over time. How do you read that? That is change in displacement over change in time.
Yeah.
So what would that be? If you differentiate it, so sine omega t, so that differentiation becomes cos omega t. And
Yeah.
since you are differentiating with respect to t, so the coefficient of
W.
t also, omega t
Theta.
also gets differentiated. So
Yeah.
it shall become a omega cos omega t.
Yes.
Understood or not?
Yeah.
So what have we gone? A omega cos omega t. Yes or no?
Yeah.
So this is my velocity. So my velocity has come up to be a omega cos omega t. Understood or not? Right?
A. Yes.
And now the change in velocity dv by dt, that shall be what? That shall be what?
Uh,
A
negative
omega
A.
negative of A. This is going to become sine omega t because cos omega t is differentiation is sine omega t.
Yes.
So cos omega t's
And
differentiation is minus sine omega t, and omega t's differentiation is omega again. So and one omega is
yeah,
already there, so it
omega
becomes
square.
a omega square sine omega t. And what is
Yeah.
a sine omega t? A sine omega t is x. A sine omega t is x. So dv by dt is nothing but acceleration. So acceleration is equals to minus omega square x, because a sine omega t from equation 1, this is my
Mm-hmm.
equation 1, this is my equation
Yeah.
2, shall become, this is my equation 3 that I've derived. So a shall become
Yeah.
minus omega square x. Understood or not?
Yeah.
So this is the equation of SHM. This is the equation of SHM. You understand?
Okay.
So how do people
Yeah.
basically write it down? People say this way. So what is velocity? D by dt of acceleration. D by dt of dx by dt. Because obviously, what is
Mm.
dx by dt? Dx by dt is velocity. So can I
Yeah.
substitute dx by dt here? Can I substitute dx by dt here? Tell me. If I can substitute dx by dt here at velocity, would you understand that d by dt of dx by dt is nothing but d2 times d2x by dt square?
Yeah.
So if I basically talk of acceleration, acceleration is nothing but d2x over dt square, and that is minus omega square x. So in your books, what equation you would find? You will find this equation. So they will say d2x over dt square plus omega square x shall be 0. So this is what they say is your equation for SHM. But my point of understanding here is that if you ever have to understand SHM, always understand that acceleration is directly proportional to displacement. The more you are taken away from the mean position, Pradiksha.
Mm-hmm.
So A has been
Yeah.
taken away. The more you are taken away, the more are the chances to return back. You understand? There is always
Yeah.
a restoring force coming, bringing it back to the position. So the moment
Yeah.
the more the shadow goes away, the faster it is going to come back. So there is an acceleration directly dependent upon the displacement from the mean position.
Yeah.
So the basic understanding of SHM is that acceleration is directly proportional to x. More the displacement, more is the acceleration in the opposite direction. If x is forward, if you have displaced the body forward here from A to B, the restoring force
Mm.
is going to bring it back. The acceleration shall always be towards the mean position because the ball B always has a position of coming back to A. You understand?
Yeah.
Right? So that is the concept. Understood or not?
Yeah.
Right?
Yeah.
So how do I put it down again? Let me just brief it out. So from the diagram, you got to understand that x is equals to a sine omega t. Why did I write omega t? Because it was actually theta, and theta over time was omega. So theta came out to be omega t. Understood?
Yes.
So dx by dt shall be a omega cos omega t. You understand? And dx by dt is nothing but velocity, and dv by dt is nothing but acceleration, and that becomes minus a omega square sine omega t, because we are differentiating cos omega t. So
Yeah.
d by dt of cos omega t is sine omega t, and omega t's differentiation is omega, and a is already there, where a is the amplitude. So this is my equation 1, this is my equation 2, and this is my equation 3. And thereby, when we have the acceleration, and when we have the velocity, and when we have the displacement x, you understand
Mhm.
my point?
Yeah.
So that is acceleration. Understood or not?
Yes.
And also you understand that a sine omega t is nothing but x. So I can say acceleration is nothing but minus omega square x.
Yes, ma'am.
Now
Got it.
understand one more thing. Do you understand that sine squared theta plus cos squared theta is 1? That's a basic trigonometric identity,
Yes.
right? So when we say that sine squared theta plus cos squared theta is 1, can I say for the same theta? But what do we have it right here? We have sine square theta is nothing but omega t. So sine square omega t plus cos square omega t shall be 1. What shall be cos square omega t? It shall become 1 minus sine square omega t. Are you understanding?
Yes.
Right? So cos square omega t shall be nothing but sine square omega t. And thereby, if I have cos square omega t as 1 minus sine square omega t, do you understand? Do you understand that cos omega t shall be under root of 1 minus sine square omega t?
Yes.
Now, from equation 1, you understand. From equation 1, what would you understand? That x over a shall be sine omega t.
Yes.
So, can I substitute that right here? So, this is my equation 5, and let me substitute the value of sine omega t here. So, what do you think my cos omega t shall be? My cos omega t shall be under root of 1 minus x over a, x square over a square. Because here we are using sine square omega t. So, so
Yeah.
cos omega t shall become what? Cos omega t shall become under root of 1 minus x square over a square. So when we have 1 here into a square into a square. So what do we have
Mm.
in here? We have a square minus x square over a square. Over root, under
Yeah.
root, under root. So that simplifies for me. So cos omega t for me simplifies as what? Simplifies as a square minus x square under root, and a square over under root becomes a.
Yeah.
Any doubts on this? So what do you
No.
think the velocity, the first, the what do you think the equation 2 modifies to? So velocity shall be what? A omega. Cos omega t's value is under root of a square minus x square over a. A cancels a. So velocity comes up to omega into a square minus x square. That's the expression for the velocity of the shadow. You understand?
Sorry, how did you get the velocity one again?
Did you understand up till now? Here, cos omega t?
Yes, until here I got it.
Until you got it. Now, just substitute this cos omega t here into the formula of velocity. Because here cos omega t I need to substitute. So a omega was already there.
Okay, got it.
So I
Understood.
substituted that particular value. So for me, it became under root of a square minus x square. Because one a came out of the bracket, no? So a cancels a. So
Yeah.
omega into a square minus x square. Yes or
Yeah.
no? Any
Yes.
doubts in this?
No. Ma'am, will they ask in the exam like derivation of the formula?
No, this is important for you to understand where I got it from basically. If I have to calculate the kinetic energy of the shadow, of the SHM, of the body undergoing SHM, if we have to do the kinetic energy of the body undergoing SHM, what would that mean? You tell me. So it shall be half mv square.
Well,
And when it
yes.
is half m, what is the velocity we just calculated? It was omega into under root of a square minus x square.
I am.
So the velocity part you put in right here in the formula, because that's the kinetic energy of the shadow which is undergoing SHM. So it shall be what? Half m omega under root of a square minus x square. So it is going to become half mv square. So it shall become half m omega square, and square cancels the root. So you get a square minus x square. Simple. Do you understand?
Yeah,
So
this is
that
just
shall
your
be the
subs.
exactly. That's the point. Do you understand my point?
Yes.
So one more, this is one specific part that you need to know, that you know how we are calculating the kinetic energy of the body which is undergoing a SHM. So for that you should know that you know it also has an angular velocity, because we are comparing that particular body which is undergoing SHM with a periodic motion, because SHM is also a periodic motion, and we have taken into account the circular motion as a periodic motion. I hope you're understanding.
Yes.
Right. So that is the concept. Simple. Yes or no?
Yep. It.
Now, next
Yes.
concept that we have to understand is this part. Just see. Next part is this. Now, understand. So, we did amplitude, we did frequency, we did time period, we did kinetic energy, we did velocity, we did acceleration, all the parameters related to SHM. And let's suppose we
Yeah.
have this particular bob, right? And when we have this particular bob, right? When we have this
Mm-hmm.
particular bob, this is going to undergo like this. 1 second. So my point is that you know when we are talking about the omega, so I told you that you know any time in any point in time, if I hold the bob right here while moving up, so I would say that you know it is going to make an angle theta. So let's suppose I gave you an example that you know it is going to do mm, 60 degrees angle in 5 seconds. So in 5 seconds it is going to move up by 60 degrees. But is 5 seconds the total time period or just the time? Just any time? Because in this amount of 5 seconds time, what is happening? You tell me. What is happening in the 5 seconds time? It is just moving from position A to position B.
Yeah.
This 5 seconds is not full time period.
Yeah.
So if I say that, you know, 360 if I say in the 30 minutes time, in the 30 seconds time, it is moving 360 degree. Then I would say that
Yeah.
30 seconds is the capital T. So there is a fine notation. Small t would represent any time, and capital T shall represent the full time. You understand?
Yes. T. Capital T is the period, right? So it's one
Yes,
full
full time.
revolution.
Exactly. Yes, yes. For full revolution, what is the time being taken up by the bob to move, to
Yeah.
start moving from point A and to continue moving up till you're back to point A? That is the full time period, and that full time period is capital T. Understood or not?
Yes.
So when I'm writing omega, and let us suppose I stop anywhere in between. So it would be theta over time, because theta is any theta over time.
Yes.
But there is also a possibility that I allow the bob to move one full round, come back to A, and then I say that, okay, you have traveled 360 degrees, which is basically 2 pi radian, in capital T time. Don't you think that total distance 2 pi angle over total time, that is also omega? Because what is omega? Angular velocity. And angular
Yes.
velocity is angular displacement upon time.
Yeah.
So angle, you could write down this angle either in 360 degrees over full time, but the SI unit is 2 pi radian. The SI unit is radian. I hope you're understanding.
Yeah.
So that means what? That I do not need to write down the 360 degrees, but when I say 2 pi over t, 2 pi over t, I hope you're understanding. What does that mean? You tell me. What does that mean? It means it is 2 pi by t. So omega could be written down in two ways now. Now I have a look. Theta over time is omega, no doubt of